So I'm now recording the video for net ionic equation worksheet. Now, net ionic equation worksheet is particularly for double displacement precipitation formation. Whether you have precipitate formation, if does, what happened? And you want to explain, okay, if there's a reaction forming precipitate, what's going on? And if there's no reaction for precipitate, why that's the case. So here, we first want to talk about the spectator ions. Are the ions that always stay soluble, dissolved, and aqueous in water. So what I'm interested is actually the one for precipitation. And let me show you the picture on the slide here. Now, if I have PbNO32 and then Ki into two different beakers, and they both aqueous. If I pour them into one single beaker together, PbI2 precipitate was formed on the bottom. And the K plus NO3 minus, they stay before it's aqueous, now they still stay as aqueous. But the PbI2, before they are aqueous, now they become precipitate. So since the K plus and NO3 minus stays as soluble aqueous before and after, they are so-called the spectator ions. So when I write down the net ionic equation, meaning like what actually going on for precipitation, you see that K plus NO3 minus, they are not involved in net ionic, because net ionic is talking about what happened in the precipitation. Okay, so the one that I'm not interested are the one called spectator ions, and they should not be included in the net ionic equation. Okay, so right here we say that the spectator ions, they should not be on the final net ionic equation, and they should show up in both sides. Okay, they show some both sides equation like reactant and products. They show some both sides with the same coefficient, same charge, and same state. Same coefficient, same charge, and same state. So for example, 2Na plus, 2Na plus aqueous. Okay, 2Na plus aqueous, 2Na plus aqueous on both reactant and product. So if they shows up exactly same on both sides, I can cancel them. So this worksheet, you have to always balance the equation, no matter you have reaction or not, because we want to show what happened if you have reaction and what happened if you don't have reaction. Now, we have the molecular equation Me, total non-ionic equation TIE, and then NIE equation. So we want to balance everything, right? Balance the equation. And then whenever we see AQ, we have to separate the compound whenever we see AQ, because AQ meaning soluble, that means they separated. Whenever we see PPT, that means they settle down, so we should not have separation. So we first look up, after we balance the equation, we look up AgNO3. Since it's aqueous, we can take the AgNO3, cross over back to form the charge, or you know the original charge for AgNO3. You write down how many and then the state. So AgNO3, we cross over, or we know the original charge is Ag plus. So 1 Ag plus AQ, and then I have 1 NO3 minus AQ. And here I will have 1 K plus AQ, I cross over, and then 1 Cl minus AQ. Arrow. Now, AgCl PBT is no separation, so I just copy here. And then 1 K plus AQ, and then 1 NO3 minus AQ. Okay, so this is so-called total ion equation, meaning what is included in the beaker before and after mixing. Okay, like how many things totally. Now next is we're looking for spectator ions. So they shows up on both sides with equal coefficient, charge, and the state. So I have 1 Ga plus AQ on the reactant, but I don't find anything on the product, so I cannot cancel, just leave it. I find 1 NO3 minus AQ on both sides. 1 NO3 minus AQ on both sides. So I cancel 1 NO3 minus AQ separately, like individually, okay? I also can find 1K plus AQ, so I cancel 1K plus AQ. Now, if you get for example, you get 2K plus 1K plus, you can cancel because they're not exactly the same. All right? Or if you get, let's say, 2 CU plus, 2 CU2 plus, they are not the same charge, you cannot cancel them because you did something wrong. Okay? So after I cancel all the spectator ions, I will write down finally the net ionic equation, meaning what's going on the precipitate. So net ionic equation is after I cancel out all the spectator ions, whatever left over in the equation. So I got 1 Ag plus AQ plus 1 Cl minus AQ equals 1 Ag Cl PBT. So this is exactly what happened for the PBT. Now here I can write 4 conclusions. I'm just asking you to write down the notes. You don't need to write down for every single question. Okay, this is just like for you to know. So the conclusion, number 1, the equation is balanced. I got 1 Ag on both sides, 1 Cl on both sides. So the equation is balanced. Number 2, the charges. I don't know if you remember back to Unit 4 when I taught you balanced ionic equation. I asked you to calculate how many total positive, how many total negative. They must add up to be 0. So I get 1 times positive 1, which is plus 1. I get 1 times negative 1, which is negative 1. They add up to be 0. The 0 meaning the charge of AgCl, which is 0 charge. Number 3, if I cross over, I will get my product. Ag1 plus Cl minus, I cross over, I do get AgCl, which is matching. And number 4, it also match my double displacement criteria, is both reactants are aqueous and also one product is PBT. So it matched with what we learned before.